appreciate the opportunity to be here in Barcelona. It's been a few years since I've been here, and so I've enjoyed returning. And the clicker is very sensitive. There we go. So as James was talking, and he was talking about how things have changed over the years, I was reminded of a Forrester report. They first came out in 2006, and they were measuring how long people would wait for a website to refresh, a web page to refresh. And in 2006, they said people would wait up to 4 seconds. Okay? They did the survey again back in 2009, and the wait period had gone down to 2 seconds. I look at it now, I'm thinking, I can't even imagine myself waiting 4 seconds. And the reason I thought of this is I was reading a New York Times report. They did a study towards the end of 2013, and their results showed that people were only willing to wait about 400 milliseconds, right? So things have definitely changed. And so I want to start out by talking about some cloud use cases and what's prompting those use cases. The first one I want to talk about, I'm actually going to, even though I could use company names, I'm not going to use company names, but because I'm not here to endorse any particular company or their efforts. But the first one I want to talk about is there's an entertainment media provider in North America, and their challenge is that they've got 55 million devices out there that they want to update. They need to update, right? We're entering this world of interactive and smart TVs, right? It's no longer passive, I just flip the channels and see what's on. I want to watch what I want to watch, when I want to watch it. I want to watch it how I want to watch it, and I want to rate it, right? I want to provide that feedback. So they've realized they've got to make that a smart device. They've got to upgrade those 55 million devices. The second challenge, they realize that to do that, they've got to provide those services close to their customers. So the advantage they have is their data centers are distributed throughout North America. Challenge is they've got to get that technology out closer to those users of those devices. So the way they're doing that, of course, is with cloud. And their challenge is to provide the technical agility, the efficiency, and the velocity to their business, right? Getting that momentum, getting the technology out to where they need it. Second example is actually a case here in Europe. When they fire up their experiments, they gather a terabyte. I'll name this one since they're not a commercial entity. It's CERN, right? When they fire up that collider, Tim Bell was telling me they gather a petabyte of data per second. That's a lot of data, petabyte of data per second. Okay, so their challenge is they got to take all that data that's gathered from all those sensors, munge that. When they munge it down to about 6 megabytes of data per second. But the big challenge is once he's gathered that data, he's got to supply that to all those users. So he's got about 44,000 users, 10,000 physicists scattered around the world. Okay? How do you get that data, compute it, munge it down, make it available to those physicists so that they can turn around, run their analysis on it, run their simulations on it, and get the results back that they need? How do you do that in an agile way, reutilizing that equipment? Well, again, the way they do that is with cloud. The third example has to do with elasticity. And we talk a lot about that in cloud, but why is that so important? And again, another example from North America. This company, in North America, we have a phenomenon called Black Friday and Cyber Monday. We've heard of that, right? When I mentioned that in Asia, they kind of looked at me like, okay, Black Friday, that sounds ominous. So the gentleman, when I talked to him about this concept of Black Friday, he showed me a graph, right? And in their case, a lot of their traffic is browse and search, okay? And so they graph the browse and search throughout the year, and it's pretty much a flat line. It looks like, you see the old heart monitors, it's a flat line, and all of a sudden, there's a spike. And that spike happens to occur around Black Friday, Cyber Monday. And what he said is on that holiday, the Thanksgiving to Christmas holiday, there in North America, they receive about 7 times the traffic okay? 7 times the traffic. Now, as a business, you can't turn that away, right? And as I started out saying earlier, our expectations are we're not going to wait 4 seconds for a web page to refresh anymore, right? You think about it, there's so many alternatives out there. The page doesn't refresh quick enough, we're gone, we're off to the other seller, right? So he's got to deal with that spike, and he has to be able to deal with it in a transparent way that I, as a user and consumer, can't see a difference. But yet he doesn't want to have to keep that equipment hanging around for the rest of the year, so what does he do, right? That's the problem of elasticity, and the answer for them has been cloud. There's all kinds of examples. We can go on and talk about service providers. Again, it's not just being a service provider anymore. It's in the position of we've got to provide high-quality services to the needs of our customers. And we also have to align the businesses with those needs. And then again, one of the interesting things that have fallen out with the advent of cloud is it's fostering collaboration in ways that businesses never thought were possible, both at the developer stage, consumer stage, and as a corporation, just the lines of businesses are now communicating together. A very interesting phenomenon. So these are some ideas, and if you look at these examples, they're very different, and their needs are very different, okay? But yet, they're all able to use, and the examples I gave, they're all using OpenStack. And the reason they're able to use OpenStack is because of being open source and open technology, they're able to adapt it to meet their needs, their specific needs. So we did a survey, and it was interesting, the question came up earlier. We did a survey at the Linux Foundation to ask people, why are you using open source? The first answer that came back is it shortened their product development cycle, right? If I don't have to write the code, if I can reuse something else, it shortens my product development cycle. The second one that came back is it makes it faster to get to market. So people are able to produce their products faster and deliver them faster. The next answer that came back was it reduces their development cost and their engineering costs, which makes sense, right? We're reusing, getting things faster, cost goes down. But the next answer that I thought was very interesting and very revealing is that people in corporations are using open source because it creates a better relationship between their partners and their customers, okay? And I'll show you an example of why this is so relevant here in a minute. But if you think about it, an open source community is no longer just the people writing code, but it's comprised of people of many different talents and comprised of people that are using the software as well, okay? And it provides that opportunity for direct communication. Next week, I'll actually be in New York at the Linux Foundation event for the end users. And it's an opportunity for end users to talk directly to the kernel developers, right? So we'll have all the kernel subsystem maintainers there talking directly to CIOs and CXOs of corporations and expressing their needs and how to get things working the way they want them. So now I'd like to talk about OpenStack in specific and why is it different? What is it that's making it so successful? Because there are other cloud open source projects out there, but what is this differentiating OpenStack? And the first one has to do with its missions and principles. So we all know it's actually a very new project. We're going to celebrate our 4th birthday here in about 6 months. Well, not even 6 months. We're July, 2 months, sorry, in about 2 months. So it's a very new project. Yet it's hugely taken off as far as participation and growth in both numbers and the amount of code that's being delivered. It was created back in 2012, and the first thing we did is we wrote down a statement and said, this is what we're about. Okay, OpenStack is about developing cloud, not just cloud, but open source cloud that meets the needs of both public and private clouds providers. And we wanted to make it simple to implement and make it massively scalable. Okay, so You've probably seen this statement. If you've seen OpenStack presentations, you've probably seen this statement over and over and over again. And you think, well, okay, that's nice to say, but it really is important because it gave us a foundation to go out to people and say, this is what we're about. Okay? This is what we're trying to develop. This is the vision that we have of what we're trying to create. And because of that, people were able to say, we get it. Now we know what you're doing. We can join in and participate on that. The second thing we did is we said, here's our principles. Here's the principles that guide our community. And the first one is we're open source. Everything is open. We're not partially open. We're not open core. We're open source. We're governed by the Apache license, which is a very liberal license. And all the code is freely available. The other part is we said that our processes are open. Okay? So everything is done transparently. We use the very rudimentary tools, good old IRC and wikis and so forth. Everything is out there so you can see it. All the features and functionality are designed out there in the open. They're down in blueprints. So you can go out there to see exactly what we're working on over the next 6 months. It's all out there. It's all available, and so you can see it. And then the last one is we said our community is open. And when we started this was actually a little bit of a controversy. Everybody kept saying, oh, there needs to be some type of rules about who can join and who can participate. And we just pushed back and said, no, the community is open, okay? And so everybody and anybody joins. The second one is the fact that the way we design software. So we wrote down a bunch of design tenets. When we started, the project consisted of 2 components, right? Compute and storage. Now, when you just have the 2 components, some of the design tenets, probably, people were going, well, whatever, doesn't make that much sense. But today, there's over 25 different components, okay? And so all of a sudden, these design tenets are very, very important. So the concepts of shared nothing, concepts of testing everything become very important, and it helped make the project successful. Now, I wanted to delve a little bit into the technology side of this today, and I wish we had time to delve really deep, but I don't have time to go into each of the modules. And as I said, there's about, depending on how you count them, there's 24, 25 different components out there today. So instead of trying to talk about them individually, maybe I'll just try to talk about them in kind of layers. At the top layer, you have the management portion, right? And this is the stuff that these slides are actually a little interesting. So this is your interface. This is the front end to the infrastructure piece. This is where the users and the admins come in. You get your dashboard type of view, your graphical view, right? As an administrator, you come in and administrate your cloud, set the limits, set the rights that a user can see, set up the types of projects and how many virtual machines, how much storage space, all that kind of stuff. So it's the graphical vision of the cloud that the user can see. It becomes the primary communication points into the cloud. And again, as I mentioned, this is where you set the limits that the user can see. So from a user's perspective, I can come in and do my self-administration, my self-service type of stuff. From the administrator, I'm coming in, setting up those limits for that user. The second layer is the service interface. This is where you see the APIs. This is where you see the command line interfaces and so forth. It's also the layer where you see the services that get launched for the platform as a service and software as a service. So we have components in here, some of which are very new actually in this space, for launching, so services for launching databases, services for launching message queues, services for launching analytics, data processing, big data type of stuff. The next layer is your layer for orchestration. And this is the layer where you do IT process automation. Thank you. I had to take a breath there. This is where, using orchestration, you can align consumer demand with the resources that you have available. So you're putting down rules, saying, okay, I'm trying to automate the way my services are rendered, where those services are located, and so forth. And I do this through all IT automation processes. A lot of the businesses that I've talked to, when you go in and talk to them and say, yeah, I'm interested in cloud, but it has to fit our company's business processes, okay? And so this is a layer that gets very important to them because they want to plug cloud into the way their business operates so that they can minimize risk and maximize automation and don't have to do it all through manual and administrative overhead. The next layer is actually the important layer in my mind. This is the heart of the system. This is where you deal with your capacity management. Okay, so this is the modules for compute and your storage and networking pieces. And this is where your resource allocation actually occurs. This is the heart of the engine. It determines things like where your workload is placed, when things will run, the scheduling services, when things actually get run, where they get located. This is what gives you the on-demand aspect of cloud. Then the next layer is what I call the virtualization layer, and there's probably a better name for this. But this is what enables us to get big, right? We talk about cloud scaling. This is where we get the scaling, because what we've done here essentially is isolated the layers from the hardware. We've abstracted out and made a separation, what I call a separation of duties, right? So we've broken things apart and isolated them out. So it used to be we talked a lot about virtualization and the hypervisors, and it's not just those anymore. Not to say they're not important, right? But it's the virtualization for the hypervisors so that you can get different architectures involved in cloud. But it's also the virtualization of your networking layers so that you can do advanced networking concepts, firewall as a service, DNS as a service, network isolation, geographical isolation across data centers and so forth, those kinds of concepts. The other area is in storage, abstraction out of the different storage types, block, data, object, and file systems and so forth. And so these kinds of concepts are very much, we hear it in terms of data center virtualization and so forth, are very important. And then the last one, of course, is down the hardware layer. And it's, we used to talk about the hardware being the backbone of your cloud. And it's still very important, right? But you've got to have those enterprise-capable, not just operating systems, but hardware and communications infrastructure to support all this. Okay, so with all those different layers, there's been a lot of change that's occurred with OpenStack over the last 3 years. As I mentioned, we started out with 2 components. We're up over 25 now. But I think one of the distinct advantages of OpenStack has been that we've now delivered 9 releases. Okay, that's a lot of releases. And we're on a 6-month cycle. And so this latest release was in April. Our next one will be around November. We had over 1,200 people contribute code, okay? And our organization, we have about 16,000 members. So remember I said the organization is an open community, 1,200 of which contributed code, which actually raises an interesting question. So if you have 16,000, subtract off the 1,200, what's everybody else doing, right? So just to, as a sidelight here, just talk about a little bit, what are those other people doing? Turns out we get all kinds of talents that are participating in OpenStack. And if you've ever attended our summits, you'll find they're very interesting because of all those different talents. So contributions come in many different forms. If you attend our summits, you'll go into a design session and you'll notice we have folks that are participating. They don't write code, but they're very good at doing user design, or they're very good at doing technical documentation. We also have people that are very good at doing marketing, okay? So when you go into these design sessions, you'll find that you've got a whole set of different talents sitting in the room talking and discussing the ideas about the design and features of these blueprints and how the code should be implemented. We have users sitting there at the table that are part of our membership, and the users are saying, you know, that's not going to work for me because in our environment, it just doesn't fit, right? So by being open and by having all these different talents participating, we get a much more robust design on our feature sets and much more viable ecosystem. So out of those 120 or 1,200 developers, about 120 of those came from about 120 organizations. And I use the word organizations because they're not all commercial, okay? We have all kinds of universities, governments, nonprofits, and so forth that are involved. The number of features for this release was actually lower this time. So we had about 350 new features. The previous release 6 months ago, we had about 420, 430 features. So it actually went down, which was a good thing because that was intended, right? For the last 6 months, we said, whoa, we got so much growth. There's so many new lines of code. We need to step back a little bit and do a little more effort on stabilization and maturing the code. And then I shouldn't use the word here. We had about 2,900 bug fixes. I shouldn't use the word bug fixes because I used that once and somebody said, boy, your code is buggy. And so it's really 2,900 commits, as James was talking about GitHub. So we're just talking about commits there. And the software is now in about 16 different languages. So again, all those talents aren't just code, but offering translations and so forth into the different languages. Now, just to give you perspective, you're all familiar with the Linux kernel. It's another big open source project. It's about roughly the same. If you look at the statistics, the number of companies involved with Linux that are actually contributing code is about double the number of organizations involved. The amount of developers and the amount of features and the amount of bug fixes are actually about the same. So in a 6-month period. So relative-wise, these projects are about the same size, which is pretty amazing when you consider the age of Linux versus the age of OpenStack. So we're on our 9th release. We've had 9th release. We're on our 10th. It'll be called Juno, coming out in later this year. So the next advantage of OpenStack is just, as I mentioned, the size of our community. So we have over 16,000 members, and those members are spread around the world, which makes for very interesting community dynamics. Of course, the number one area is out of North America. Number two is actually out of Asia. So we have a ton of developers out of the Asian countries. And we held our, not the last summit, but the previous summit we actually held in Hong Kong. And just to give you an idea of the growth, the first summit I went to was in San Francisco. About 2 years ago, we had around 700 people came to the summit. The next one we held in San Diego. We had around 1,300 people. Then we went up to Portland. We had about 1,700 people. And the Asians were saying, hey, come on, it's not fair. We can't all make it to North America. We need to hold it in another location. So we said, okay, we'll try Hong Kong. And it was with some trepidation because we kept thinking, well, how many are going to come to Hong Kong, right? And turns out we had over 3,000 people show up at Hong Kong, which is really amazing, considering it was a new location. We were unsure about the size. And The also part that was very interesting was when you have a community, and these, I need to mention, these summits are very technical. So they're not just a business conference where everybody shows up and stands up on stage and gives a presentation and goes away and leave. These are working events, right, where we're designing the features for the next release. And so we had to make sure we got the core people there. So out of those 3,000 people that showed up, we had our core set of developers there. So it was a very viable working summit. The last summit we had was in Atlanta about 4 weeks ago. And we had over 4,000. Actually, we had about 4,700 people show up. So the community continues to grow. Next one's going to be in Paris in November. It'll be interesting to see how many people is going to show up for that one. It's going to be very interesting because space is actually tight. So the community continues to grow. We have about 355 companies involved. I should say organizations. Well, no, actually, that's companies. So these are folks that are supplying some type of monetary contribution to the project. And as I mentioned, so we had about 1,200 participate in the last release. Cumulatively, we've got about 2,000 people that are supplying code to the project. So it's a very viable, very fast-growing project. Our The other part that's interesting is when we started, as I said, we laid out our mission, we laid out our project principles, we laid out our design tenets. And the effect that had was when we went out to talk to companies and organizations and say, hey, you should come and participate in this project, they said, you know, reading your mission, reading your principles, and the design tenets, we understand what you're doing, we understand how you're doing it, we can participate in that, right? So the corporate type folks looked at it and says, I get it, we can come in and back that. And so we've had this huge momentum of people joining OpenStack and participating. And if you look at it, and of course I don't have everybody's logos on here, but if you look at it, we have at least the top 3 vendors for many of the different areas of the industry, for the hardware, operating systems, networking, management, hosting, and so forth, service providers. And the effect of this is, and I'm sure you all recognize, and James mentioned it earlier, there's a strong need for talent out there in the industry right now. And if you look at the cloud space, many of these vendors are just dying to hire folks, right? There is a strong need for people and for talent in this space. And if I'm a company and I want to jump into the cloud space on my own and do something in private, it means that if you go back to the slides I talked about earlier, if you look at all those different layers, if I'm going to try to create my own cloud product, I've got to get talent in all those different areas, right? The networking, operating system, virtualization, management, scheduling, orchestration. I got to find talent for all those different areas. That's tough. In this environment, that's tough. But the advantage we have with an open source project, and one that's very open and able to attract this kind of industry backing, is we get to leverage each other, okay? So I work for SUSE, and SUSE's strength is virtualization and Linux operating systems, right? So SUSE comes in and they bring in their talent in those areas. We get to work with the companies like the Ciscos and Junipers and so forth. They're very strong in the networking space, so we get to leverage their talent. The IBMers, the HPs, the Intels, those folks come in with their hardware expertise, architecture expertise. So everybody comes in, brings their experts to the table, and I get to leverage them and they get to leverage me, okay? That's where you get innovation starting to happen. Now, we also compete. So as I mentioned, all of these folks here are coming in with the intent of building a product. And so we're collaborating, we're sharing expertise, but at the same time, in some spaces, we're competing. And so you'll find that we just released an area we call the marketplace, where vendors can actually list the products they're selling. We had it's growing very fast. We just released it 2 weeks ago. And there's up over 100 different vendors now stating they've got some type of product that they're selling, right? So you're going to see a wide variety of products, many of which compete. And the reason I want to point this out is we're collaborating, but yet we're still able to compete. And I could throw up many different slides here, but I just wanted to put one up here because the way we compete is all these companies are taking OpenStack and combining it in different ways with other software to focus on their particular markets, okay? So this is just a picture of SUSE's, what they call SUSE Cloud. And the boxes in gray are actually the components that come from OpenStack. And so SUSE combines that with other additional, in this case, open source software, and delivers that as a product. And you'll find that all the different vendors are combining it in different ways. And so even though we're collaborating and you're thinking, well, it's all commodity then because everybody's collaborating, people are adding value by combining it in different ways with other components and delivering their solution to their particular market segment that addresses their needs, okay? So that's how we collaborate, but at the same time can compete. Now, as I mentioned, we actually, as part of those 16,000 users, we have a user group that participates. So we have a whole bunch of users that are participating within the open source project itself. And they produce a survey about every 6 months. They're trying to align that survey with our summits as well. And so they're surveying the users. Now, it's very interesting if you've been in open source for a while, you know it's very hard to know who's using your software, right? Where it's free and anybody can download it, you typically have no idea. All you know is somebody downloaded your software. You have really no idea what they did with it. So finding out who and how many people are using your software can be a very big challenge. So these are by no means our definitive numbers, right? But they're just a sample set that we're getting from people that are using our open source software. So this is the results, just a synopsis of the latest results. Of who's using the software and how it's being used. But I thought it was very interesting to see the business drivers, of course, of why people are choosing OpenStack. And the first one, of course, as I mentioned, goes along with the survey I told you about earlier, is cost savings. But the one I thought was very interesting, and it ties back to how I started this presentation and those different types of uses. One of the big reasons these companies and organizations are using open source software is the flexibility of of choice, right? The flexibility that the technology gives them. And again, as I mentioned, our design tenets, the way we've designed those components, they're very separable, and people can put emphasis on certain areas and less on others, right? Doing that, they can tailor the software to meet their needs. And so we're able to, through open source, to meet a whole range of needs. And that shows up both in adoption and both in the number of products that are being produced through open source. And again, number 5, I think on the list there, is the reason they're using OpenStack is their ability to innovate and compete. So the other thing that I thought was interesting is we talk about who's using OpenStack, just the range of different deployments. So we have information technology, so your corporations internally are deploying OpenStack. Academic research, education, Telecommunications, the telecommunication folks are just gobbling this stuff up. They've got a lot of work to do. They've gotten behind in their technology, gotten a little slow, and they're using cloud to catch up. Film, media, entertainment, I gave that example a minute ago. Government and defense, manufacturing, retail, healthcare, finance, consumer goods. Those are very different vertical markets, but yet all of them are able to adopt and use OpenStack because of its open source nature and the flexibility that it gives you. So just as closing here, two things. As I mentioned, it's a very open community. If you want to see what's going on, just go out to our website. You'll see directions there. You can go down, check out the blueprints, see what the features are that are coming up and what we're working on. You're welcome to check out into our community, join the IRCs, the mailing list, so forth, and see what's going on there. And then, like I said, you can sign up on the mailing list, join as an individual member, or so forth. And I put also on the left-hand side here, I didn't realize they put this graphic in here, but the thing I wanted to point out, if you want to try it out, I know cloud can be a little daunting to try to set up, right? But if you're interested in just kind of seeing what it looks like, just go out to that link. It's actually out there on SUSE Studio. We built an appliance image of it. You can just go out there and follow that link up there on SUSE.com and just run test drive. And you can just kind of get a flavor and see what all this is we're talking about. And if you're interested, then you can just download the appliance and give it a try. So anyway, I appreciate the time to talk about OpenStack. It's a very exciting project. It's growing very dramatically, tons of interest and tons of success, actually. And with that, I thank you. Do we have time for questions? Or are we running behind? Okay, any questions? One question, yeah. And then we'll take a break. I don't see a mic. Is that a statement or a question? Question.
I haven't seen any change in Horizon in a long time. I guess people are not using it, or?
Actually, they are using it. There is, yeah, and this goes back to the question. We get the question, oh, it's just the OpenStack itself is very immature, and we've been fighting that general statement. There's components within OpenStack that are very mature, and there's other components that are very new. And so some of those aren't as mature as others. And I didn't talk about a project. We're actually working on a project where we're going to help people understand which components are core to the project, which ones are the stable components, and which ones are a little more newer. So there actually is quite a bit going on Horizon. It actually kind of tends to be more of the laggard because the blueprints for it tend to be filtered over from the other projects, right? So when I want to implement cells, for example, that affects Horizon. So it's kind of the after effect. So Horizon does tend to be a little slower in some of those areas, but there's still. I talked to the PTL at the Atlanta Summit, and he still seems pretty pleased with the amount of involvement in the project. It's hard to see anybody. One last question. Okay. Oh, yeah, James. Oh, is it back? Sorry, I can't. All I see is the bright lights. If we were in New York, I could give you my New York joke about the bright lights, but.
Well, maybe next time. Yeah, I think my question is just that you put forward all of these organizations are participating, and nominally that seems good, but sometimes having too many people involved too many cooks spoil the broth?
Yeah.
Is there not a danger that there are too many cooks, and how are you going to manage that going forward?
So there is that can be a danger. In fact, we've had discussions, as I mentioned, when you have 4,700 people show up for a design summit, and this is actually for doing design, it can be a very big problem because you're sitting there as a bunch of engineers trying to design out a feature, and some guy's going to raise his hand and go, can you explain to me what this component even does, right? He just dropped in, thought the summit was really cool, and he just wants to see what's going on, and they can totally derail the function, the process. So the first thing is we keep having discussions with our leadership saying, okay, here's how you manage those types of interruptions. The second thing we do is it's a meritocracy. So I didn't have time to go into the details, but each one of the projects, so each one of those little blocks there, those technical blocks, those 25 or so different projects, has a lead, okay? Each one of those leads are elected. We used to elect them every 6 months, but they're now elected once a year, so that they'll go through a year process. That person leads that project for the year. He's elected by those that are contributing code, okay? So we have an open membership, but for project leads, it's only those that are contributing code. So to influence a project, you've got to be contributing to the project, okay? Second layer we have is the technical committee. So out of the project leads are part of what's called a technical committee, and it's the technical committee is elected through those that are contributing to the project. They're making the technical decisions, so it's not the 230 some odd companies that are there supplying money. So it's not the board of directors coming in and saying, thou shalt do these technical types of things. It's the technical committees led by the project leads who are voted on by those contributing code. So the effect is those that are contributing code are the ones that are making the technical decisions and setting the direction for the project. So if you want to come in and usurp the project, you're going to supply more resources, right? And that's the way you do it. Luckily to date, it's actually wouldn't even be that simple because like back on the question on Horizon, one of the things the technical committee does is it reviews the blueprints, it reviews who's contributing, and for a project to even stay alive, we have to make sure one of the things we check is we make sure that contributions are coming from more than a single company. So we're very much aware of the people that are contributing. We're making sure that they're ones that are those that are contributing are the ones that are involved in making the decisions and setting the direction for the technology. All right, thank you.